Well, once again, welcome to Statistics 29, Normal 7. So that's what this video is. And what we're looking at in this case is how do we use the standard normal table to find z-scores for areas to the left. So what's going to happen is we're going to be given values in the table. In other words, we are given probability or percentage or something like that, and then what we want to do is we want to find the z-score that corresponds to that. And so this is really important when we do confidence intervals and hypothesis testing. So that's one of the reasons we want to do this. It also helps us do some comparisons too. Okay, I'm going to set up a problem and then show you how to do it. So here's the first problem. What I see is that the probability is equal to 0.7580. What I want to do is I want to find the z-score that corresponds to that. Now, since this probability represents area to the left, and it's greater than 1/2 the area, because 1/2 would be, the mean would be the correct number. But in this case, this 0.7580 represents the area. And what I want to find is the z-score that corresponds to it. So again, always draw a picture, but this is pretty easy to do, and I'll show you how to do it in just a sec. And so what I went and did is I went and grabbed the normal table. So I'm just going to blow it up right here in front of you. And what I'm looking for is the area equal to 0.7580. And as you can see, I see that number right there, 0.7580. So what is my z-score? Well, it looks like it's 0.70. And that's exactly what it is. So let me let me erase these right here. And do this. Oops. So I thought I could shrink my table back up, but I can't. So I'll just write what the rest of the problem is on top. So what we had is the probability was equal to 0.7580. Let me change that color real quick. So we had the probability was equal to 0.7580. And we wanted the z-score that corresponded to that. And so by going to look up 0.7580, I found out the z-score was equal to 0.70, or if you wish, 0.70. And that's really all we have to do on this assignment. So on the next slide, I'll show you another application of this. So if you remember, once upon a time, we saw this notation in an earlier chapter, chapter 2, I believe, and also when we did probability. But this is the percentile notation. So if I see a p with a 32 like that, that means the 32nd percentile. And if you remember, what's a percentile? Well, once I give you the number, that means 32% is below that number. So in a normal curve, if I want to find the 32nd percentile, what that means is my area has to be 32%. So my probability is 32%. And what I want to do is find the z-score for the 32nd percentile. So I want to find that z. So all I have to do is, once again, I need to go to my table. And I don't have my table in front of you right here, but I can do that quite quickly using the table. And the 32nd percentile is on the negative normal distribution. So it's 0.3200. and it looks like the closest one is negative 0.47. So my z would equal negative, negative 1.47. Okay? And that would be the 32nd percentile. I think I got that right. I may have looked at my table wrong. So let me look again. 0.32. Okay, so it is a 0. I apologize. This is a 0 right here. And so what I did is I went to the table, and what I found was a 0.3192 and a 0.3228. So what I did is I grabbed the one closest to what I was looking for, which was 0.3200. So I grabbed this one, went back out, and got my z-score. And here I had negative 0.4, and up here I had 7. So negative 0.47 is the z-score. And that's all you have to do this problem. Now, this little thing I did right here, if you're generally closer to one of the numbers, just grab that z-score. If you're exactly halfway or within, 1 or 2 10,000ths of halfway, then you would continue it on. And if I had been like at 0.3210, so if that had been my probability, 0.3210, which is exactly halfway, then what I would have written for the z-score is negative 0.475. I would go halfway between 0.47 and 0.48. And that's, your textbook makes a point of that when you do it. Okay? If you have questions, I want you to bring them to class tomorrow. So, tomorrow's little brief quiz is, your homework is numbers 2 through 24 even in 5.3. And the second thing that I want you to tell me, besides what is the homework, is I want you to tell me what the calculator statement does. So I'm going to do that on the next slide. So the calculator statement is called the inverse normal. It is number 3 in the distribution window above vars. And the syntax for this is, the announcement. The syntax of this statement is probability to the left, mean, and standard deviation. So there's only 3 things you have to remember. So if you give the probability to the left, it'll give you the z-score for probability to the left. So it works just like your table does. And this is really important for the inverse normal statement. All right, it's basically doing things backwards. Give it the probability, it'll give you a z-score. And so to what you need to bring tomorrow, besides telling me this, is based on what I've said here. I want you to bring me the answer to the problem we just did, which is, what is the 32nd percentile, the z-score for the 32nd percentile? Okay? And you can do that right when you get to class on a calculator, and that'll tell me if you know what you're doing. Okay, talk to you later. Bye.